Hello, my name is Bryce Brown, and today I will be demonstrating an acid-base reaction. And in this reaction, I will be using a constant base, which is baking soda, also known as sodium bicarbonate. And sodium bicarbonate has a pH around 9, so it's kind of like a weaker base. So it's not considered a strong base, which that would be around like 12 or 13. And so I'll be demonstrating an acid-base reaction with various acids, and those acids include vinegar, or also known as acetic acid, and that has a pH around 2.6, so it's a little bit of a stronger acid. And also have lemon juice, which is also a stronger acid. It has a pH range from kind of 2 to 3, so it's also. And then I have two weaker acids right here, just apple juice and orange juice, and both of these are around 3 to 4, so they're a little bit of a weaker acid compared to these two. And lemon juice is mainly citric acid, and I said earlier vinegar is acetic acid, and orange juice is citric acid, and apple juice is malic acid. And so in this reaction, as I mentioned earlier, that there's a acid and a base, and so what happens in this reaction is it ends up producing a salt. So which in the lemon juice and baking soda case, that salt is sodium citrate, and it also produces water, H2O, and in this case it's also going to produce carbon dioxide, which will be in the form of the gaseous bubbles that you'll be able to see. So with that being said, I'll get into it and start demonstrating the reactions. So first we'll start off with the vinegar. So as I mentioned earlier, this is one of the stronger acids I'm using. So, and in these cups I have around 3 teaspoons of baking soda. So, and I'm gonna pour probably around a little under an ounce of each liquid into it. And so for the first one, I'll go ahead and begin. And as you can see, the bubbles foam up pretty high right here. And it's a pretty quick reaction too, and that's the carbon dioxide, and it also produces water and a salt. So, and then so for the second one, we'll do orange juice. And so this is kind of a weaker acid compared to vinegar. So as you can see, it still forms bubbles, but it's not nearly as quick and intense of a reaction as the vinegar was, but it's still forming the same products. So, and then you can see the liquid layer under the bubbles a little bit, so still there. So, and next we'll do apple juice, which is similar to has a similar pH to what orange juice has. And so as you can see, it's not nearly as an intense reaction or anything like the other one. It just kind of foams at the top, and I mean, it's just, there's not much to it. You kind of swish it around to make some more bubbles, but it's not a very big reaction, mainly because it's not a strong acid that's in orange juice. It's weak acid. So, and then last we have lemon juice, which I mentioned earlier is citric acid, and so this is also a stronger acid. So, and you see that the reaction is not as quite quick as the vinegar was, but it's surely a lot quicker than the orange juice and apple juice, and it foams pretty high bubbles for the amount of liquid I've poured in there. So, and as I mentioned earlier, those are the carbon dioxide bubbles. So that's pretty much it. These acid-base reactions, each reaction all produces carbon dioxide and water, and then it produces the salt that gets derived from the acid and base that are involved in the reaction. So